All right, welcome to the second day of chapter 4.3. Now I'm going to start off by listing some strategies that will help us prove these identities. Now, these don't always work, but these are just some suggestions for you to look for. The first thing that you want to do is generally look for things that you can replace, because once you have things that you replace, then you can simplify them. Another thing you can do is rewrite everything in terms of sine and cosine. That works most of the time. However, sometimes that won't work. So just keep in mind that's just a suggestion. Another thing is think about Pythagorean identities if you have squares. That means if you have cosine squared, sine squared, cotangent squared, all of those squares, look at your Pythagorean identities. They might help you solve that problem. Now we want to add fractions if you have two parts and only need one. We'll want to simplify fractions whenever possible and multiply it by versions of 1. Now multiply by versions of 1 means that sometimes we'll need to multiply it by sine over sine. Say if we're trying to find a common denominator, because sine over sine equals 1. Another version of 1 that we might have to multiply by is sine x minus 1 over sine x minus 1. Again, this is also 1. We'll get more into that later on. Alright, if we multiply these together, x times x is x squared, 3 times x is 3x, x times negative 3 is minus 3x, and then 3 times negative 3 is negative 9. That should be a 9. There we go. So this plus 3x minus 3x cancels out, so we have x squared minus 9. Now we'll do the same thing with sine. 1 times 1 is 1. This would give us a minus sine x. 1 times plus sine x will give us a plus sine x. Negative sine x times sine x will be minus sine squared x. Again, the minus sine x plus sine x cancels out, and this is just 1 minus sine squared x. Now, squaring this is the same thing as saying x plus 3 times x plus 3. When we do that, x times x is x squared, 3 times x is 3x, x times 3 is another 3x, and 3 times 3 is 9. Now here they don't cancel out. When I add 3 plus 3, that equals 6x. So x squared plus 6x plus 9 is the answer. We'll do the same thing with, even if there's a sign there, 1 minus sine x times 1 minus sine x. Multiply the first two together to get 1. The insides are going to be minus sine x. The outsides are going to be another minus sine x. And then the last one, a negative times a negative is a positive, and this is sine squared x. So this would be 1 minus 2 sine x plus sine squared x. Now this problem, we're going to want to prove the identity by working with the left-hand side to get the right. The first thing I want to do is multiply. So 1 times 1 will give me 1. Inside will give me plus cosine x. The outsides are going to be minus cosine x. And then the last are going to be minus cosine squared x. So the plus cosine minus cosine cancels out, so it's just 1 minus cosine squared x. Or if you look at the identities on top, we can subtract cosine squared from both sides. And 1 minus cosine squared will just be sine squared x, which is what we wanted. Alright, for this problem, there are a couple ways we can approach this. We could distribute this first, Or we could simplify everything in the parentheses and then multiply it by cotangent. I think it might be easier to simplify everything in the parentheses first. So let's try that. Tangent is going to be sine over cosine. And this is multiplied by sine plus cosine. Now sine times sine is going to be sine squared. And that's alpha plus cosine alpha over 1. Now, when we add these, we need common denominators. So this is going to be sine squared alpha. That's not written very well, but hopefully you can read it. Now, our denominator will just be cosine, so we don't have to change this left side at all. This right-hand side, if I multiply the denominator by cosine, I have to multiply the numerator to get cosine squared theta. Now, when I combine these, I'm going to get sine squared plus cosine squared, which if we look up at the top, sine squared plus cosine squared equals 1. So when I add those, sine squared plus cosine squared, that's just going to equal 1 over cosine alpha. Now cotangent is cosine over sine. So that times 1 over cosine, you'll see that your cosines will just cancel out, leaving 1 over sine, which equals cosecant of alpha. Now in this one, 1 minus sine squared, we can get that by subtracting sine squared on both sides. So you'll see that cosine squared is going to equal that. So we'll start this off by cosine squared beta all over. Now cotangent, it says here, is cosine over sine. So cotangent squared is cosine squared over sine squared. Now this is the same thing as saying cosine squared beta divided by cosine squared beta over sine squared beta, which will be the same thing as saying cosine squared beta times sine squared beta over cosine squared beta. Now, if we cross out our cosines, because cosine divided by cosine will cancel out, that'll just leave sine squared beta all alone.